All right, welcome back. So, in order for us to flesh out some concepts or to basically elaborate your understanding of the production possibility model, let's construct a production possibility curve. So, we look at a hypothetical firm, Alpine Sports, and it's a specialized sports equipment manufacturer. So, a person by the name of Christy Ryder began the business 50 years ago, and basically with a single ski production facility near Killington. All right, sales grew, and there was a demand for snowboards, particularly after the snowboard competition events were included in the 2002 Winter Olympics in Salt Lake City. So what happens there is that before they used to only produce ski, so to ski along the snow and ice in the mountains. But when the idea of skateboards came about, and then snowboards came about to navigate the sand using a snowboard, it was introduced as an Olympic sport, became popular. So basically, people were coming in and say, "Oh, is there any snowboards that we can use to uh, go down the icy slopes?" And there was a demand for it. So the owner says, "Okay, I'll open a small second plant, and it's a small one, and it will only be designed to produce snowboards as well as skis." So then she also changed the first plant so it could produce both snowboards and skis. 2 years later, she added a third plant in another town. While even smaller than the second plant, the third plant was primarily designed for snowboard production, but could also produce skis. All right, so that's the background that we have now to sort of calculate the production possibility model. We can think of each of Ms. Ryder's three plants as a miniature economy and analyze them using the production possibility model. We assume that the factors of production technology are available to each plant operated by Alpine Sports are unchanged. Suppose the first plant, plant 1, can produce 200 pairs of skis per month when it only produces skis. When devoted to snowboards, it can produce 100 snowboards per month. It can produce skis and snowboards simultaneously as well. So A, if it produces 200 pairs of skis, it can produce 0 snowboards. If it produces 100 pairs of skis, it can produce 50 snowboards. If it produces 0 pairs of skis, it can produce 100 snowboards. So I'm looking at your lecture slides now. The chart given on pairs of skis per month and snowboards per month. All right, let's plot this in a production possibility curve. So you see pairs of skis, snowboards per month. All right, at 0 snowboards, it can produce 200 skis. At 50 snowboards, it can produce 100 skis. And at 0 skis, it can produce 100 snowboards. That's the graph there, the production possibility curve for plant 1. Now, when you look at the illustration, you will note that the curve is linear. It gives you 3 combinations the plants can produce, and basically it involves devoting entirely to ski production. Then it means devoting entirely to snowboard production, and combination B involves the production of both. These values are plotted in the production possibility curve for plant 1. The curve is downward sloping straight line, indicating that there is a linear or negative relationship between the production of the two goods. That means an increase in one causes a decrease in the other. So it's a linear sort of relationship, and it's negative. Neither skis nor snowboard is an independent or dependent variable in the production possibility model. We can assign either one of the vertical or the horizontal axis. Here we have placed the number of pairs of skis on the vertical and the number of snowboards on the horizontal axis. Alright, the negative slope of the production possibility curve reflects the scarcity of the plant's capital and labor. Producing more snowboards requires shifting resources out of ski production and thus producing fewer skis. Producing more skis requires shifting resources out of the snowboard production, thus producing fewer snowboards. So as a result, you would see that plant 1 is producing 100 pairs of skis and snowboards and 50 pairs of snowboards per month at point B. Now consider what would happen if Miss Ryder decided to produce 1 more snowboard per month. Alright, the segment curve of the point R and B is magnified in figure 2.3. The slope of a production possibility curve. The slope between points B and B is 2 pairs of skis or snowboard. Producing one additional snowboard at point B requires giving up 2 pairs of skis. When you produce one additional snowboard, you are giving up 2 pairs of skis. We can think of this as the operating cost of producing an additional snowboard. This operating cost equals the absolute value of the slope of the production possibility curve. Alright, now you look at figure 2.3, the slope of the production possibility curve. You see that if it wants to increase, that little circle there is magnified here. So if it wants to increase, let's say from B, you want to increase snowboards from B to B, you would see that it will basically be -2. So he wants to increase production from B, which is 100 skis, to B in the middle here, the middle B. You would see that the skis will come from 100 B down to 98. That means that it's increasing by 1. And the snowboards will increase from 50 to 51. So that means that the cost of producing one additional snowboard is actually 2 pairs of skis. That's what we mean when we talk about the slope of a production possibility.